Hello, friends, and welcome to Pathologic Volume 4, Episode 6. Today we are taking a little diversion from our typical shading and line drawing puzzles to a number placement one. This is called Kakuro. If you're not familiar with it, it is one of the more popular ones, but not so much as, say, Sudoku, so it might be new to some of you. And it should be a nice breezy solve for us, it looks like, given the size of the grid. So I'm looking forward to doing that together with you, and we'll do that right after we take a look at the rules. In a Kakuro puzzle, we will place digits, which all have to be from 1 to 9, no zeros, in the white squares in the grid so that digits that see each other don't repeat. So this is a little bit like a Sudoku constraint, sort of, or Latin square, in that we don't have repeating numbers in rows and columns. But the distinction is this next rule. Digits can repeat within the same row or column as long as there's a gray square in between them. So, back to see each other. This is a somewhat informal way of saying in the same row or column, but not blocked by a square. So, for example, these squares all see each other. In this column, this one doesn't see this one, which is why they're allowed to be the same number. They're blocked by this gray square. Each clue gives the sum of the digits that it sees in a straight line. A clue at the top right of its cell sees the line of digits to its right, up to the next gray cell. A clue at the bottom left of its cell sees the line of digits below it, up to the next gray cell. So, for example, this 7 clue here is in the bottom left triangle, which means it is referring to the 2 cells below it. This is a fairly intuitive where the clues go, but here's an example here. This square could have possibly 2 clues. This one in this position would refer to the cells below. One in this position refers to the cells to the right. And as you can see, 3 plus 9 equals 12. Those are the rules of Kakuro. So it's time to solve a puzzle. Today's Kakuro puzzle was set by Clover. I took the liberty of transcribing this puzzle and the example into the Sudoku pad interface because I find that a lot friendlier for number puzzles than Puzzlink, and this was not too hard to port over. So we've got our rule of thumb, which is to look for big numbers and little numbers, and in this case, in the case of a Kakuro puzzle, you have to judge what a large and small number is compared to the number of cells it refers to. And if you've internalized any number combinations from a killer Sudoku, that will be helpful here. But just starting in the top left corner, I happen to know that whenever Clover sets a puzzle, that's where she tends to focus first, so that's usually where I try to look first for an in. And I do see an in. This 3 is as small as you can get for 2 cells, because you can't have a 1 and a 1. They have to be different. So just to spell out what I'm thinking here, so those have to be 1 and 2 in some order. But this 11 tells us how that goes, because if this were a 1, we'd be left with a 10, and you can only have a single digit in a cell. So this has to be a 2 to make this 9, the most it could possibly be. And therefore, we've done these first 3 cells. This 12 now comes next, because the 9, 12 minus 9 is 3, so we're left with 2 cells that add up to 3, and we know that's a 1 and a 2. And we got a 1 right here. So this is the 2, this is the 1. The It's a little unfortunate that the 1 went here, because one of the things I know about 3 cells with an 8 is that it has a 1 on it, and now that 1 is taken care of. So now we're left with 7 left in 2 cells, and that could be 3, 4, or that could be 2, 5. So lots of choices there, and the 18 doesn't give us a whole lot to work with. So let's maybe look somewhere else. Up in this corner, where 3 is the smallest we can get in 2 cells, 17 is the largest we can get in 2 cells. So that's a 9, 8. And I can tell which order they go in because this clue is a 9 and needs that one of those and another cell. So this can't be the 9, or else we need a 0 there, and that's not allowed. So this is the 8, this is the 9. Now the 9 gets a 1 to finish up the 8 plus 1. Now in this row, we've got 12 with a 9, so that's 9 plus 1 plus 2, same thing that happened over here. The 2 goes here, the 1 goes there. And we've got another 8 with the 1 already given. So, so does that give us enough to deal with this 18, I wonder? Before I puzzle that out, I'm going to look for some more easy stuff. I see some 6s in 3 cells. The only way you can do that is 1, 2, 3 in some order. So I'm just going to pencil mark that in on all these 6s. And a 7 has to be 1, 2, 4. It's the only way you can do it in 3 cells. There's another 7 here, which is 1, 2, 4. It crosses across this one, so this is not a 3, because you can't have a 3 in a 7, in a 3-cell 7. Okay. That gave me some stuff. A 10 in 4 cells is 1, 2, 3, 4. In some order. That might be it for the gimmies. So a couple places I could look next. I think, oh no, there's a 7 here. Let's take care of that one. That 2. That's a 1, 2, 4. And so therefore this one's not a 3. Okay, so again, a couple places I could look next, but let's go back up to this 18 and see if it actually is, if it's easier than it looks. Oh, this 1 sees this 1, so that's not a 1. Okay, what could these be for our 8s? We said these could be either 2, 5, or they could be 3, 4. So these cells are from 2, 3, 4, 5. Does the 18 restrict that at all? If we maximize these, where 1 is a 4 and 1 is a 5, that gives us only 9. So this 18 does restrict it, because even at their maximum, this one has to be at least a 9 in order to make an 18. So this is a 9, and these two are maximized at 4 and 5 in some order. And that now tells me this one is not a 4, because that would make this number a 10. So this is a 2. 2 plus 5 plus 1 is 8. That gives me a 4 here. 1 plus 4 plus 3 is 8. And now I see our pencil marks will kind of collapse a bit, because this 2 takes 2 out of these, making this is a 1 and this is a 4. The 1s come out of here. 3 comes out of here, which means that the 3 in this column has to be right here. And how do we make an 8? 8 minus 3 is 5, so it's either 1, 4 or 2, 3, but this can't be a 3, so it is 1, 4. Putting a 2 down here. This now sees a 2 and a 4, so it is a 1, making that the 2, making that the 4. This 10 needs a 1, 2, 3 left. Okay, this 12 has a 1, 2, 3 here. We can use that because the only way that's going to work is with a 3, because this would still have to be at least 9, can't be higher than 9. So that's 3 and 9. That takes 3 out of these. 1, 2 with the 10. 1 would go with 9, 2 would go with 8, but it can't be the 9, because then we'd have 9 and 9 seeing each other. So this is a 2 and an 8. 2 goes with a 1. 1 comes out of these. So now we got a 2 and a 3 here. This 14, is that constrained? Not as much as what happened up here, because we could have 4, 3, and then this could be 7, or it could be an 8 or a 9 with lower options there. So that probably isn't where we look. This 20, how constrained is that? These two can add up to at most 17 if it was a 9 and an 8. So this is at least a 3, but not quite enough to force it. Is it this 8? 8 with the 4, so these are a 1 and a 3. Now, in this row, we don't have a 5. So, to make an 8, we need to do 1, 3, 4. And that tells me this is a 3, therefore that's a 1, therefore that's the 4. And the 3 will give a 2 there, and the 1 will give a 3 there. Now in this column, 4 will tell me that one's a 3. So these 3 and 4 come out of here. And now I've got a 3 with the 20, so it is maximized at an 8 and a 9. And here we've got 14. Let's maximize these. 2 and 3 give me 5. Away from 14 is 9. So if we maximize these two cells, and then we still need at least a 9. That's all we can do. So these are maximized. 2 and 3. That gives me this 2 down here. 2 gives me a 1 there. And now the 1 is going to tell me what's happening in this column, because if this were a 9, we'd have another 1 in order to make 10, and we'd have two 1s next to each other. So this is an 8, and this is a 2. That means this is a 9, and we finish off the puzzle by saying 12 minus 9 equals 3. And that is how we solve a Kakuro.